So as part of this project, the overall conveyances project, we had to do a mussel survey because there was records from the state of threatened species in the Chemung River in this area. So a mussel survey was completed in 2021, and it identified that there were, in fact, a state threatened species, the green floater, in this section of river, which could potentially be impacted by the project. So based on the state law, for threatened species, they have to be protected. Impacts have to be minimized to them. Since they're already rare within the state, we don't want to be harming their populations anymore. And so we have to make sure that this project will end up being a net benefit to the species. So we're doing some mitigation to account for any impacts the project may have. As part of that mitigation, we have to relocate the green floater and any other mussels we find out of the area where the pipeline crossing is going through. And so we went back out in 2023, just before the in-water construction, and we developed with the DEC relocation protocol and plan. And following that plan, we had an identified relocation area, salvage area, that was going to be potentially impacted either by dewatering or potential construction impacts. And we divided that area up into 10 by 10 meter cells, which is the maximum size allowed under the DEC protocol. So here you can see the divers entering the water. We have our transects laid out. We're following the DEC mussel survey and relocation protocol, and the maximum size for each area is a 10 by 10 meter cell. And so you can see these transect lines that the divers are lining up against. In that area, we have to spend 100 minutes. 1 minute per meter squared is our search rate, since we're looking for green floater. That's the state threatened species we're dealing with on this project. Since they're small and relatively hard to find, there's a higher search rate. We need to spend more time per square meter looking for them, just to make sure we don't miss any in doing this relocation. So the divers are working in teams. We're getting in line along these two transects, and they're going to start their search. There's a dive supervisor on shore and a safety diver that are recording the time, and they'll be monitoring how long the team is spending in each cell to make sure that they meet that minimum time requirement. As the divers are searching, they're going to be looking visually for mussels, and then also tactile search using their hands. They'll be moving the sediment, feeling for mussels, and then as they're disturbing that sediment, as the current moves that plume away, you can then look and see if any mussels turned up that you didn't see visually. So as the divers are moving through, you'll see they're kind of trying to cover this entire cell. We're moving into the current to keep the turbidity down, and our task here is to cover this entire 10 by 10 meter area. And if we need to, we'll spend additional time in areas where there's a high density or abundance of mussels. We'll spend extra time there just to make sure that we're getting all of them, especially all of the state listed species. In this case, again, the green floater. Once the divers have completed the time in that cell, they'll bring their mussels back to the processing area. We'll leave them in the water in a mesh bag so that they can, continue filtering and respiring while we're waiting for processing. Each bag is labeled so we know which cell and which pass it was from, and we have to do multiple passes. If mussels are not discovered in the first pass, we don't need to do a second pass. If we do find any mussels, then we have to do additional passes in there until we meet either no state listed or endangered mussels on that final pass, and we're having less than 0.1 mussels per square meter. So that's just requirements to make sure that we're spending adequate time and that we're not missing mussels or not missing too many mussels before we move on to the next area. So here you can see our crew. They're actually wearing snorkel gear here, not dive gear, because we're in shallow water. This is the transect lines. These are what we're using to make sure that we're covering this entire area and that we're staying within each 10 by 10 meter cell. This is actually a yellow lamp mussel. You can see it filtering. You can see its siphons and its soft tissue out above the sediment. This is what we're looking for when we're down here diving and visually. And now the diver is going to remove that mussel. And as you'll see, when that mussel is anchored in place with its foot, it's a soft, fleshy part that it's using to anchor and move up and down within the substrate. That's that foot right there that's still kind of extruded from its shell, it'll retract that back in. Now that it's, being handled, it doesn't want to leave that soft body part out, so it's retracting it. It's covering up, putting everything in its shell for protection. And then we'll then put that in a bag that he has attached to his waist, and then we'll continue with the rest of that cell. Again, doing a visual survey, looking for those mussels that are open and siphoning, and then we'll also go through with our fingertips and actually move the sediment and tactilely feel for mussels that are buried under the sediment, and then go back through and just visually look and see if we've turned any over. As part of that tactile search, sometimes you'll kind of turn some over that then you can come back and see after the water current has carried the sediment away, and they'll kind of be laying there more obviously on the top. You can pick those up and add those as well. Again, the goal here is to move all of these out of this relocation area where they might be potentially impacted, and move them upstream where they're going to be out of the way for the project.
And then I dip it in water, gonna wash it off. I need to dry it, very technical. And we have two types of tags. This is a shellfish tag. It has a unique number on it. And then we have pit tags, which we can electronically get the number off of. Right there. So in terms of the anatomy, you hold the umbo away from you, which is the beak structure. This becomes the anterior, this is the posterior end. They like to be in the substrate like this with their anterior in the ground, and so they filter feed through the posterior end siphons. Whatever valve falls in whatever hand is the right and left. So this valve here falls in my right hand, so it's the right valve in the left. So what we'll do is we'll put on the shellfish tag on the left valve, and we use a little bit of glue. And then we use our forceps to put the C towards the anterior, and we place it in there like such. And then we use this, what is called an accelerator. We just spray it and automatically helps cure the glue. All right, so that's for the shellfish tag. And then on this side, we're going to use the pit, what is passive integrated tag. We're going to do the same thing on the right valve. This is a small little guy, so the tag is about 12 millimeters. So it's a kind of big on it, but we put it up here, shouldn't bother it. And we hit the accelerator and let it cure, and then we will put it in the bucket of water until we relocate it. This is the pit tag reader, so that's going to read this tag here. And the nice thing about this is it's on a wand, so we don't have to see the mussel when in the relocation site. We can use this and it'll give us a ping just like a metal detector does. All right, so I have to, because it's not a number like the shellfish tag, I have to get the pit tag's number. So what I'm going to do is hit read, and I can pass it over, and there you can see. And that's our number, 982-09-107-0699287.
here we are taking a mussel back up. This is in the relocation area. We're putting it back into the substrate in the proper orientation, the way that we collected it, the posterior side down so that it can use that foot to burrow into the sediment, and that the top is up so that it can siphon and filter to get oxygen and food. So this is in our relocation area. This is where we've actually moved mussels. You can see in the center of the screen here, that's one of those shellfish tagged green floaters. There's a larger one. You can see the shellfish tag and the pit tag on the other side of its shell. It's open, it's siphoning, it's, circulating water. It's doing well in its new home. So this is the ultimate goal of the project, is moving these threatened species up here, get them out of the way so that they're not negatively impacted by the project.
So there's an interesting phenomenon in freshwater mussels is called sexual dimorphism. You can tell differences between males and females of the same species. So got this same species side by side, relatively same length on these, right? Do you notice anything different about the two right offhand? No? Well, to I guess a more trained eye, this is a female and this is a male. You notice that the female looks a little thicker in width and a little more truncated. You see this here? This is so that the female can hold the glochidia that are located in the gills. And so this gives her more capacity to hold in her gills millions of young freshwater mussels. And so that's kind of the phenomenon of sexual dimorphism in species. So not all species do. Lampsalis, this genus of Lampsalis, tend to do that.
What's the host fish for the yellow lamps?
Usually for Lampsalis is some sort of sight feeding fish, so smallmouth, bass, anything like that, because what they do is the females in particular, what they will have is, this is the posterior end, they have a modified mantle that looks like a minnow that floats in the stream, and so the smallmouth or any sight feeding fish will come in, hit it, and that triggers her to release her glochidia in her gills and broadcast it into the gills of the fish. And they'll stay on there for a couple weeks, and then they just passively fall off in the stream as the fish migrates and does its feeding and other behaviors.